Hello, this is from Dalian. We start. Hello, can you hear us?
Yes, yes, yes.
Okay.
We have just started the webinar, so just waiting for participants to have time to come. Hi, Anshok, how are you? So, good afternoon, good evening to everybody for this fourth panel discussion in the frame of the ITA 2021 awards. And this live panel discussion will be with a finalist of a category 50 to 500 million euros. And we have three finalists in this category, but they will make a short presentation of their project, and then we will have a discussion. To moderate this discussion with me, I have the pleasure to have Davide Fabri, who was one of a member of a panel of judges, and we have Jayataran Kurasamai and Angshok Choi, ITA Executive Council member, Jaya being the chair of the ITA Awards Committee. So we have as a finalist in this category, Egg Jiandong, who will present large diameter shield tunnel engineering project in karst strata of sea area. We have Wang Changong that will present the Pyongyang tunnel on Chengdu Langzu railway line. And we have Francis Lanquet, who will present the south extension of the Metro Line 14 in Paris. This morning we had two presentations on line 14, but it was the line 14 in Shenzhen, China, so it's not the same one. And so let's start with presentation by A. Jiaodong.
Thank you. Take over. 现在我们共享服务，然后每10秒做一个。Hello, ladies and gentlemen. We would like to make a brief introduction on our project, the large diameter shield tunneling project in karst strata of sea area. The project is located in Dalian, Liaoning Province, China. It is the control project of Dalian Metro Line 5, which breaks the traffic restrictions due to the bay and solves a single north-south travel mode in Dalian City. We have done a lot of research on the design and development of shield tunneling machines, karst detection, treatment, and the submarine excavation technology of large diameter shields. In this project, we have done a lot of research on the design and the development of shield tunneling machines, karst detection, treatment, and the submarine excavation technology of large diameter shields. By now, we have come out with a number of innovations. The tunnel has a total length of 2882 meters and adopts a single hole double layer lining structure. It is the largest undersea subway tunnel in China.
I do not have the slides on screen.
Exam, we cannot see your screen. Exam done.
No, that's better.
Uh,
Yes,
can
that's,
you,
I can see it now.
you
Could
can,
you, well, you have to start
Okay.
again. Yes, please.
okay. Okay, I'll start again.
Okay. Can you put it in a full screen, please?
要全屏的，最大的。
有问题全屏。
Well,
Can you say the in full screen
no,
now?
no. Okay, we don't see when it's in full screen, so maybe you have to leave it in in a slides way
Press escape.
or escape. Yeah.
Can you see
Yes.
our slide now?
Yeah, let's go like this.
OK，就这样吧，就别全屏了，都看不见。
嗯，看他们说到这儿了。他说
Our project is the largest diameter shield tunneling project in cost strata of sea area. The project is located in Dalian, Liaoning Province, China. It is the control project of Dalian Metro Line 5, which breaks the traffic restrictions due to the day and solve the problems of a single north-south travel mode in Dalian City. We have done a lot of research on the design and development of shield tunneling machines, cost detection, treatment, and submarine excavation technology of large diameter shields. In this project, we have done a lot of research on the design and the development of shield tunneling machines, cost detection, treatment, and submarine excavation technology of large diameter shields. By now, we have come out with a number of innovations. The tunnel has a total length of 2882 meters and adopts a single hole, double line, double layer lining structure. It is the largest undersea subway tunnel in China. The tunnel segments have an inner diameter of 10.8 meters, an outer diameter of 11.8 meters, and a ring width of 2.0 meters. The secondary lining is 30 centimeters in thickness. The section under sea is 2310 meters long. The water depth is between 9 and 14 meters. The maximum buried depth is 49 meters, and the maximum water pressure is 0.5 megapascals. The tunnel goes through a 1538-meter long, highly developed cost area and 3 major cost cave groups covering over 1,000 cost caves of various sizes, with a maximum cave height of 29.8 meters and the highest compressive strength of 118.2 megapascals. We completed the following innovations in the project. First, we developed the cutter heads for which the tool can be replaced under normal pressure for high water pressure cast formations. The cutter heads can be inspected and replaced under normal pressure, which avoids the risk of tool replacement under high pressure and ensures the safety of life. A mounted type cast cave detection and treatment systems of advanced full rotation and integrating drilling and injection was developed. With this system, we can carry out the detection and grouting reinforcement in areas 30 meters ahead of the tunneling phase. This ensures construction safety of the shield in cast formations. Secondly, determine that the combination of borehole and elastic wave CT scans was the best method to detect cast in the sea, which solves the problem that the conventional exploration methods cannot be implemented in the sea area, and establishes the geophysical point layout technology in the cast area, which improves the detection accuracy and simplify the process. Third, we developed a marine cost treatment method which solves the problem that the traditional grouting has poor sealing performance and cannot adapt to the sea environment. And real-time monitoring can be realized by underwater high-definition cameras to protect the marine environment. Fourth, the key construction technology of large diameter mud water shield crossing the high water pressure cost stratum in the sea area is formed, which solves the various difficulties of large diameter shield tunneling in the cost stratum in the sea area, provides reference for the shield crossing the cost stratum at home and abroad, and the stratum adaptation range of the shield tunnel in the sea area. Over the past 4 years, CCTV, People's Daily, Science and Technology Daily, Xinhua News Agency, China News Service, Liaoning Satellite TV, and other news media have reported more than 40 times that the project has conquered the worldwide difficult problem and the super crossing the sea. And the super crossing the sea construction news and the documentary, fully affirming the construction achievements of large diameter shield tunnel project in cost stratum in the sea. The shield machine passed through 1538 meters fast strong development area safely and smoothly, and no safety accidents occurred in the construction process. To protect the surrounding marine environment, 5,000 square meter mud water site was established, which can screen and classify the slag excavated by the shield. The filter press separated the waste mud into solid phase particulate filter case and the pollution-free clean water, so as to realize secondary utilization of the resources. Since the beginning of construction, the project site has been used as one of the venues for Dalian Natural's open day to citizens. We have established a good social relationship through public visits, joint public welfare activities, and volunteer services. The project construction has won the support of the residents of the surrounding communities, and they speak highly of the super sea crossing project. Thank you for your attention. That's our presentation.
Thank you. Thank you very much for this presentation. So we will come back at the end of the SRIP representation with discussion and questions. So now I give the floor to Wang Hong that will present the Pyongyang tunnel on Chengdu Langzu railway line. Can you stop sharing so one can share his screen?
Please quit her. Please quit the screen sharing.
Yes.
Thank you. Thank you. Hello, everyone. My name is Chang Hong. Could you see my screen?
Yes, perfect.
Thanks for you listening and watching. Today, the presentation of mine is the Pyongyang Tunnel on Chengdu Langzu Railway. The railway starts from Chengdu, Sichuan, and ends in Langzu, Gansu. The total length of the railway is 727 kilometers. The design speed is 200 kilometers per hour. The total length of Pyongyang Tunnel is more than 28 kilometers. It is the longest railway tunnel that has been built in the southwest of China. Let's look at the longitudinal section of the geology. Pyongyang Tunnel is located in the typical stratigraphic section of Wenchuan earthquake belt. There are so many faults and synclines and overturned anticlines. The geology is very complicated. For the purpose of the acceleration, the speed of construction, we built connecting L77, GR6 transverse galleries, and 2 inclined shafts. The total excavation length reaches more than 70 kilometers. The main measure for the tunneling in difficult geological conditions, we organized the scientific research team to take out field surveying and laboratory test. For example, we take out the friction test on site and take out the uniaxial compression test in laboratory. For the application of 5G information technology, we built a shared platform for all of the stakeholders. And we used the beam to locate the bridge and the tunnel. The visual system was used for monitoring all of the construction process during the whole time. For the prediction of the unfavorable geology, we strengthened the advanced geological forecast. For example, we use TSP of seismic wave refraction to depict the geology variation before the tunnel phase. And also, advanced boreholes were drilled before the tunnel excavation. There is major unfavorable geology, the rock burst. Here, the well load cable is damaged by the rock burst. For the countermeasures, we may strengthen the rock burst prediction and applying the suitable construction method, the full ring excavation, and improve the degree of mechanized construction. There is another unfavorable geology, high ground heat. The countermeasures, we may strengthen the ventilation. For example, the temperature is reached 38 degrees, spring the cold water and place the ice cube. And for other labor protection measures. The seismic composite lining has been adopted in the earthquake zone of the class 5 surrounded rock. The deformation zones are set in the tunnel every 13 meters. The full cross-section inwards mechanized supporting construction technology has been used. For example, the 3 booms drilling jumbo and on-site grouting by manipulated robots has been used. Based on the work, we obtained several patents of utilized model and invention. For example, the rock bolting jumbo for chute crate and rock bolt support. For the environmental protection, at first we selected the low water route, reduced the excavation elevation, bypassing the natural reservoirs, conserved soil and water resources, and purified the water, and prevented the dust and reduced the noising by the sound barriers. Second, the logistic support for the construction of the super long tunnel. Emergency medicine and cold drinks in the tunnel were provided. The project emergency, the warehouse provide the extinguishers, the life belts, and the emergency tiles. There is a 3D schematic diagram of disaster prevention, rescue, and evacuation system. If there is a fire disaster occurred, the smoking was exhausted from the shout type connector flue to the parallel smoke exhaust flue, and then collected with the smoke exhaust flue. Finally, it is exhausted by the horizontal flue to outside of the tunnel. And the connector IOCs could be used as the working evacuation. The fresh air was pressed into the tunnel at both ends of the two tunnels. For the measurement for reuse of the material, the tunneling ballast are used for gravel pavement and concrete. There is the screening and crushing process during the construction. More than 470,000 cubic meter tunnel ballast were used for the subgrade and the low-lying land filling. The construction wastewater from the tunnel is reaching 10 million cubic was recycled. The fuel oil equipment were replaced by the energy equipment, for example, the jumbo. The solar energy is used for the officer and the livings. Finally, I wanted to make a conclusion. The deeply buried and super-round tunnel on the high earthquake intensity rock burst high temperature has been built. Disaster prevention and rescue system achieved the goal of that shortening the time of 20 months. For the purpose, there are more goals to be achieved for the future railway construction to enable the worldwide high-speed trains of intelligent, green, environment-friendly, and energy-saving. Thanks. And that's all. Thanks for your listening and watching.
Thank you very much, Wang, for this very interesting presentation of a long and difficult tunnel. And we'll come afterwards with probably questions. Let's go now to Paris with a presentation by Francis Lanquet about the south extension of Metro Line 14.
Okay, so let me share you my screen. Oh. Is it okay?
Yes, it is.
Okay, so I start. Let's start from the beginning. It will be better. So I am Francis Lanquet. I work at CETEC, which is one of the biggest engineering companies in France. And I will present you the south extension of the Metro Line 14 in Paris. In particular, the GC02 contract. So a brief presentation of the project. So the line 14 in Paris is 14 kilometers long, and it will connect the line 14, the existing line 14, to the Grand Paris Express network. It will deserve 7 new stations. But we can say that one of the most important stations will be the Orly Airport station that will allow to link the center of Paris to the Orly Airport in only 23 minutes. I don't know if some of you have been in Paris by airplane, but we can say that today it's quite complicated to join the center of Paris from the airports. So it will be much faster in the future. And the main objective is to open the line for the Olympic Games in 2024. The client is Société du Grand Paris, which has delegated the driving of the operation to the RATP, the historical client for the metros in Paris. The project manager, which I belong, is Elios joint venture, which is constituted of CETEC and Sistra, two engineering companies in France. And the construction group is Vinci and SPI joint venture. The leader of this joint venture being Dodin Campenon Bernard. So to describe the global project, we can say that there are 5 ancillary works in order to ventilate the tunnel and to allow the safety exit. 4.6 kilometers tunnel and 1 metro station in this in the GC02 contract. Here we can see the vertical alignment of this project. There are 2 particularities. One of these is that we can say that the tunnel has to cross many different geological layers, and the other particularity is that we can say that on 1.6 kilometers, the TBN is built under some limestone quarries under the city of the Kremlin-Bicêtre in the south of Paris. To sum up the project, we can say that the overall construction delay is 42 months. So one important point is that we still are on time in order to open the line for the Olympic Games. So it's quite for the moment we are quite relieved, and dealing with the cost of the project. The project amount is 406 million euros at the end of the construction for the civil works. At the peak of the activity, 500 workers were involved in the works. So after this general presentation, we can focus on some particular point of the project. First, the launching shaft, whose name is Jean Prouvé. Just to mention that at the beginning, the contractor decided to replace the steel struts and the concrete beams by active ground anchors to simplify the handling operations, and the TBM installation is in the shaft. So it was quite a good idea that they had. Now we will focus on the Institut Gustave Roussy station. So this interface was a very difficult point. The tunnel has to cross the line 15, which is also in construction, at the station, which is constituted by a big shaft of 60-meter diameter and 4 caverns. And the line 14 TBM had to cross the shaft on the concrete bridge 10 meters above the invert of the station. Here you have the plan view of the station and a longitudinal cross section. We can mention that the bridge was also used to transfer the thrust of the TBM from the northern cavern to the southern caverns. And this thrust was transmitted by big threads in steel. You can see in red on these pictures. And after that, we also had to lift up the bridge in order to allow the line 15 TBM to pass under the bridge. So you can see on the left a picture of the jacking operation, which allowed us to lift the bridge on about 1.7 meter. This operation interrupted the line 15 TBM for some weeks. Then one important point I mentioned before is the excavation under the quarries of limestone. So you can see some pictures of these quarries. Basically, the quarries are constituted of galleries of about 1 meter height, partially filled with excavation material. You can see on the right a map which was done by the Inspection Générale des Carrières during the construction of the quarries, beginning in the 17th century until the 19th century. And so we decided to grout all the quarries in order to ensure the safety of the excavation under the city and under those caverns. So here you can see some picture of the works. In total, so in order to grout 1.6 kilometer of quarries on a width of about 20 to 30 meter, it took us 28 months. The works being subdivided in 14 zones. The main objective was to having finished the work before the excavation of the TBM, which will succeed in fact. Briefly, I can speak about the excavation of the Kremlin-Bicêtre Hospital station. Here, the challenge was to also to be ready to welcome the TBM on time. So the contractor used big mining engines in order to perform this operation in only 4 months. Speaking about the tunnel itself, we can mention that compacted gravel with recycled aggregates were used to build the tunnel invert. So this allowed us to reduce the emission of CO2 by 650 tons. And then to finish, one last challenge of these works was to dismantle the TBM in only 4 months in the south of Paris itself at Maison Blanche station, which offered very few spaces to perform this complex operation. So we managed to dismantle the TBM in a void of only 10 meter long and 12 meter wide, and it took only 3 months in much constrained urban conditions. That's all for my presentation. Thank you for your attention.
Thank you very much, Francis. So let's go now for discussion and questions. Can you just stop sharing?
Yes.
No.
No, I don't see my Zoom picture, Zoom window. Stop. Okay.
Okay. Thank you very much. So, and I've seen that Andres Marulanda, also ITA Executive Council member, join us for this panel discussion. So who would like to start on questions? Davide, Jaya, Angshok, Andres.
Maybe just maybe start if Anjak, if you are not, probably I can ask a question.
Yeah.
Yeah. I mean, all 3 projects has somewhat similar difficult ground conditions in terms of the geology. All has varying geological challenges, the difficult ground condition, as well as the difficult construction, crossing tunnels within the excavations, and each has their own construction challenges as well. And also I noticed that all three projects has used a lot of innovative methods, as well as to reduce the carbon footprint, recycling the material and so on. So if I ask each of the presenter to choose what is the three aspect each of you would name as the most important part for these each of the project, or which one would you consider as three most important aspect in the projects?
So I wanted to ask you this. I wanted to answer this question at the first one. Thanks for your thanks for your question. That is really a very good question, because for our Ping'an tunnel, the excavation difficult mostly come from the geology, from the long, super long distance. I think most important is the rescue and the evacuation system we designed for the long tunneling, because during the more than 20,000 days, there is no casualty, there is no any of the damage during the construction. We built this tunnel. I think just like I mentioned, the evacuation system, the smoking, exhausting, and the fresh air to the tunnel phase, I think is the most success for our Ping'an tunnel. It's not only for the awards, but is we respect the life of the working of our staffs. So I want to answer this question first. Maybe we'll bring another good idea.
Thank you.
I try.
Yes, go ahead.
Yeah, I saw during the work that one major, one of the most important thing to succeed is to have good human relationship. It can be strange, but we managed to solve the most technical, most complicated technical issues. I think that we can solve any problem, but if the relationship are not good, people don't go in the good direction, and problem become more complex. So I would say that we can do anything if only if people are good, go together in the same direction. That we, and on my experience, it was quite a success, because it was the objective of everyone to manage to build this project in the delay and with the respect of the cost.
Managing the stakeholders, yeah.
Yes.
Yeah, thank you. Yep.
Hi, this is Chen Xiaodong. The most important issue we are facing is this is the first ever project that dug the tunnel under the sea. Earlier, someone asked us the question, why have we done the comparative of the immersed tunnel against the tunnel under the sea, because the depth of the sea is only 14 meters, and it has very easy port above. If we use the immersed tunnel, it will interfere with the vessel coming in and out of the port. So that's the only option we have, is to dug the tunnel under the sea. Because the sea has many holes, cast strata holes, it is difficult to be detected. So we have integrated a lot of advanced technologies to detect and keep the machine, the digging machine, in a pre-planned route. So technically, that's the first reason for engineering survey in cost areas. That is a combination of drilling and the geophysical prospecting that's widely used. But due to the special sea environment, some of the detection measures that are effective in land cannot be used in the sea. And the sea water has a shielding effect on electromagnetic waves, so the detection has a limited. Conventional water caves are treated and building a working, normally are treated by building a working platform on the water. But the local height is almost 1 meter. And if in case of a typhoon, that's the tide as high as 8 meters, that will cause danger to the traditional method of setting up the platform. Moreover, the conventional cost grouting technology has the poor sealing performance and low efficiency. It also likely to lead to seawater to cause pollution. And how to design a shield machine to do the construction in this cost spectrum of the sea area, how to find and deal with the cost cave on the seabed, how to replace the shield cutter under the high water pressure on the seabed. So by solving these problems, only by solving these problems, we can ensure the safety of the constructor.
Okay.
Those are all the technical difficulties we have experienced. We consider that's the most important thing for us. We have overcame all those difficulties and done the project.
Thank you.
Thank you.
Thank you.
I have a Andres, go ahead.
You go ahead first, and then I'll participate after your question.
Okay, no, I have a question because all of you, and it not only now, but also in the previous thing, we all highlight the environment impact, the diminution of CO2, the treatment of water and everything. Were all these things part of a tender? So meaning that in the tender process, did you have to answer? So we will make process that will diminish the CO2, or how we'll treat the water and so, or was it something that has been done by the engineering and the contractors, but without any, let's say, constraint from the client?
I can begin with the CO2 if you want.
Okay. Let's go ahead.
It was proposed by the contractor from its own initiative. So we are thankful for it. I guess maybe there was some economical interest also, but if economy can meet the protection of the environment, it's better. So no, it was not obliged in the tender.
Wang?
Yeah. So for the decrease the dioxide, carbon dioxide too. So we used several new technologies. At first, we replaced the oil machine replaced by the electrical machine, the jumper. That is the degree minimize the release emission of the co-oxide.
But
because
was it something from the contractor initiative, or was it something in the tender process that you had to do?
So we, according to our contractor, so the government would like to provide the subsidy. So if you use the water, the contaminated water discharge would be fine. And also, if you do the better for the protection, you may decrease the taxing.
Okay.
So that is like the stimulus to push us to adopt the new technology in the dioxide emission.
Thank you.
Hmm.
Andres?
Thank you. I wanted to follow up on Mr. Lanquette's comment on the importance of handling human relationships well in the project for its success. As we know nowadays, handling different conflicting, often stakeholder interests is one of the key issues of being successful in big projects. You highlighted the importance of taking care of human relationships, but I was wondering if you could elaborate more from a project management perspective, what type of committees or strategies did you put in place to do that effectively?
I can say there was a strategy. We had to adapt to only every situation. Concerning the IGR station, it was an interface between Vinci and Vinci, so we could have think that it would be easier, but in fact not so much, because there was some competition between the branches of Vinci, so it was not so easy. Concerning the Maison Blanche, where we had to dismantle the TBM in the station built by another contractor, the problems were not technical, but it was the problem was that the other contractor had difficulties to make the studies on time, so we didn't have any strategy. You just have to adapt and to find a way to make that everyone finds its own interest. I think it must be a win-win for the two sides of the interface, I would say. So it's not easy every time, but on this project we managed to every time to make everyone satisfied, but the managing of the interface.
Thank you.
Davide, any questions?
From my side, perhaps the question to the participants about what was the design optimization under construction. We know, especially for the projects in Asia, I suppose this a client's design followed by contractor execution of the works. For the French project, probably is a design build. Design is carried out by a contractor. Les études, c'était à vous ou
No, yes, the study were made by the engineer, and the contractor only had to.
So you are all on the same base. You have to make a design to perform a design done by client in your site.
Yes.
And the question is, what you broke as optimization from your side to improve, to optimize the design which was given to you in order to speed up, to be more efficient, or did you only apply the design which was provided by the third party?
No, I did the design, and the contractor proposed some optimization. There are many optimization, but I can speak about the dispositive in order to let the TBM enter and go out of the stations. Les bouchons, I can see the English word. The treatment in order to secure the arriving and the departure from the station. We had planned many works, and the contractor proposed much simpler things that at the end of the day worked perfectly. Also, the dismantling of the TBM, we had imagined a much complicated solution with the hole being far from the entering wall of the diaphragm of the station. So the contractor proposed a solution which was simply the first time you say no, the second time no, the third time no, and the fourth time you are obliged to admit that it's cheaper and it's faster. So you at the end you accept the solution.
And for us, so as the Ping'an, the contractor, the designer agency provided the original design, but sometimes it's not adaptive for the challenging or for the change of the geological condition. So according to the contract between the designer institute and the construction contractor, we may hold the offline and online the meeting if there is any of the change of the design. If we have the design scheme, we will report it to the design agency, and we get the authorized designing the drawings and the document, and then we may put it into the real life construction. So that is the process. We have a special, like the vice deputy manager, to deal with the technology design optimization. That is the maximum diminishing the damage or unpredictable risks in our project. Yeah, David, yeah, that's my answer.
And Jaya, do you have any, Anchog, you have any questions?
Yes, I mean, can I do that? Yeah.
Yeah.
Okay. So I have some specific questions, but we don't have enough time. So I just ask you three candidates. I mean that what is your strongest point to win the final ITA award compared to the other candidates? I mean, just briefly, to explain the reason.
Who want to start?
Yeah, maybe I will make the first. Maybe first the proposer for the Ping'an Tunnel. I think the most the powerful the reason support us to win this award is that we built a deep buried super long tunnel in many unpredictable, unfavorable geology in 2,200 days without of any casualty, to build an environment-friendly green riverine tunnel. Thanks.
My turn. No.
Let's. Yeah. Hey. Yeah.
So let me put a couple more points. So to lower
Sorry, but we don't hear you clearly. Sorry.
In majority.
We don't hear you clearly.
Hello? Yeah. Hello? Hello? Can you hear?
Yes, try again.
Okay, try again. So I didn't speak, so I'll put a couple more points into my speaking. In order to lower the CO2, we have conducted majority of our purchase within the local range. Also, we have used reused the we have integrated many advanced technology to reuse the materials. Also, we have an invention for the complex material to strengthen the anti-rust against the seawater. Then we think our strongest point, if we can win this award, is we have this. Our project has solved the various very difficult problems of large diameter shield tunneling through marine karst formations. That is the single difficult project in China. It's not like in the mountain or in the city. It's under the sea. Many things are able to be seen in advance. So we have to resolve improvise. We have overcame a lot of technical difficulties to get this done. Thank you.
Thank you. Francis?
Yes, in France we have a proverb that says that we don't speak about the train that arrives on time, and in our project it's the case, because at the end we managed to build it in the respecting the global schedule, although despite of the COVID and the 2 months interruption. We also respected the cost. At 1% with only 1% of increase only, and we can say also we can underline that the design we made remained very stable along the time. So at the end of the day, we managed to perform this very difficult project with many difficult subjects that I presented you today rather smoothly and respecting many the constraints of the client. So it's our, for that we are very proud of it.
Taya, any other questions? Andres?
Perhaps not a question, but a comment.
Yep.
Logically, this year we are facing 3 really different projects in different environments, and with different challenges. Each project is facing different challenges. Logically, for the panel of judges, was not easy. I speak for myself, but can be for the colleagues to compare, because you cannot compare that projects. So what probably we are looking into these projects to get an idea what is the project of the year is really the question, what is, would say, not ordinary. Because every project is different, and probably a kind of fil rouge or of leading path is to look after the non-common parts of the projects. In the world, there are many metro projects ongoing. There are many long tunnel achieved or under construction. There are many projects with large diameter. And so if you could really say in one sentence, what is really, and not the extraordinary of your project compared to other projects of similar environment. Thank you.
So one sentence, right? That is a real difficult question, But for us, we wanted to say for the deep buried. So what is the most special for our project? I think is the human beings wealth is the respect the works, because there is no casualty for the I stressed for several times for the 2000 days for the super long time. That is most proud of this project. I think compare the other project. The human beings is the first. Thanks.
Francis?
It's a very difficult question. I will still underline it's a technical point, but I already talked about the human aspect. So dealing with techniques, I will speak about the excavation between underneath the quarries, which are quite unique, I guess, and not so many limestone quarries, and it's really, I think it's not so when it's very it's not so often that you dig a tunnel under 3 meters under such construction. So I would underline this point that we already presented in some congress, because we were very proud of this achievement that we during 4 years of design almost we focused our attention on this point, because we are very worried about the managing the risk in these conditions and very urban conditions. So yet again, it was very satisfying that during the excavation we saw no settlements, no problems. So it was our big success, I would say.
Just I will give the floor afterwards to the last project, but at the beginning of the studies to go under the quarries, did you think of going much deeper in order to be safer?
Yes.
And with iterative, you could go up and up and up.
No, indeed, at the beginning we were thinking about going much deeper, and the calculation showed us that as there are some clays under there is the limestone, and under there was some plastic clays, and we saw that digging in the plastic clays, the settlements were much higher at the surface and also on the ground of the quarries. So we decided it was not intuitive at all, but we decided to dig the tunnel as close to the quarries as possible. So we say, let's take 2 meters with 1 meter of margin. So we took a margin of 3 meters under the quarries. So it was not intuitive, but it worked.
Okay, thank you. And yes.
Hello. Can you hear? Hello.
Go ahead.
Can you hear?
Yes, go ahead.
Okay. So we concluded that we have spent a total of 6 years. The first 2 years is study the situation and the design, then took 4 years for construction. Because this is the first ever project under the sea, we have to overcome all the difficulties. In the due process, we have accumulated totally 33 patents and new model utility model patents, and one authorized software copyright. So that's mostly the technical difficulties we have experienced. that's very tough for us to conduct the first ever project under the sea, not normally done on the land. Thank you.
Okay. Okay, so I think we've gone through this panel discussion. I would like to thank all the three finalists for their presentation, and want to thank my co-moderators for this panel discussion. Just want to remind you that the award ceremony will take place tomorrow at 2 p.m. CET, so 1 p.m. GMT, where you've probably, as finalists, received an email telling you that you are invited to connect, and that when we will go to each category, you will put it as panelists, and the winner will have the opportunity to say some words when he gets the award. It was clear that in this category, as Davide said, it's difficult to choose because the three projects are very different. And as he said, it's what is the difference between a similar project, what makes it different from a similar project. Because of course, if I take all the contract of a Grand Paris Express, we could in the next years have more than 100 or 150 entries just for the Grand Paris. And it will be all there, but there are some contracts that are different from others, and the same for undersea tunnels. There are many undersea tunnels in the world, but there are some specificity, and as you said, long tunnels. And I don't know if you're a member of a working group on long tunnels in ITA, but I tell you that you could be there, because it's very important to share experience in these long and deep tunnels, because as you said, there are specific tunnels. So you are welcome. So for all of you, thank you very much for participating in this panel discussion. So the panel discussion has been recorded and will be available in the platform. And let's see each other tomorrow during the awards ceremony. So thank you to everybody.
Thank you very much.
Thank you for all colleagues.
Thank you. Bye-bye.
Thank you.
Bye-bye.
Thank you.
Thank you all. Bye.
Thank you.
Thank you. Bye.
Thank you. Bye-bye.
Thank you. Bye.